Good morning and good afternoon, and welcome to this Axiometric Solutions webinar. Today's subject is headphone testing. My name is Ole Teilgaard. I'm a Director for Support and Applications for two of the brands in the Axiometric Solution Group. Actually, the brands AP, Audio Precision, and Grass Sound and Vibration. Today's webinar is divided into two parts. I will be presenting the first part, and my colleague Santiago will be presenting part number 2. Let's have a look at today's agenda. Part 1. In part 1, we will have a look at headphone types. We will have a look at realistics test. We will look at fixtures, different fixtures, and we will have a closer look at the Grass fixture 45cc. Then we will look at challenges when doing test of headphones. And after that, part 2 will start, where Santiago will take over. He will discuss what to measure. He will discuss a measurement setup. He will give us some details about the AP audio analyzer, the APX 517. And in the end, he will actually give us a demonstration of a headphone measurement. This demonstration is in according to our AP technical note TN 143. Questions are very welcome. We will answer some of the questions during the presentations and the rest of them after the presentations. Please use the question function in this webinar. In the handout functions of part of this webinar, you will actually find the technical note, headphone measurements, and you will also find the slides, the slide deck for today. We will also make a recording of this webinar, and we will send you the recorded version here probably by the end of this week. Headphone types. We have actually 4 different types. Circumaural headphones, actually the headphone, also called over-the-ear headphones. These headphones are actually covering the whole pinna or the whole ear, so the cup are covering the whole ear. We do also have another type called supraaural headphones, also called on-ear headphones. These are actually sitting on the ear and actually pressing on the pinna. Then we have earphones or earbuds placed in the ear entrance, just in front of the ear canal. And in the end, we have in-ear headphones, headphones which are actually placed in the ear canal. For the best test solutions of these types of headphones, we actually have to have a look at the different phases a headphone actually could be in when we are making a new type of headphones. Are we in the R&D phase? Are we in the type approval phase? Are we in the product engineering phase? Or are we on the production line? The equipment will actually be a little bit different for where in this phase we actually are looking at, and that's actually what we will discuss here on the next couple of slides. Realistic test. In R&D, when we are doing type approval, when we are doing a part of the production engineering phase, then it is actually very important that the headphones are tested as realistic as possible. This is actually to ensure that the headphone has been loaded with the right impedance, just as it will be loaded when used in a real life situation. Actually, when you and I are wearing a pair of headphones. If we aren't loading the headphones correctly, then we might have excellent measurement data on our headphones, but the headphone might sound awful. So therefore, it is a good idea to test the headphone as realistic as possible, especially when we are in the R&D phase and in the type approval phase. Before we continue, then I think it's a good idea to look at some definition, the definition for a microphone and the definition for a coupler. A microphone is a dynamic sensor measuring the pressure fluctuation in the media it is used. A coupler, it consists actually of a cavity or a volume and also of a measurement microphone. The coupler simulates the human ear and the ear canal of a human, or a part of the human ear, or a part of the human ear canal. If we look at available couplers for doing headphone testing, then we have to have a closer look at a standard. We have to have a closer look at the IEC 60318 standard. This standard describes different types of ear simulators and ear couplers. The first part of this standard describes actually an ear simulator made for test of on-ear and over-ear headphones. It's the what we have here. The next part of the standard we will have a closer look at is the IEC 60318-4. This part of the standard describes the occluded ear simulator. The occluded ear simulator is a simulator, of course, simulating the human ear and a part of the ear canal of a human. So therefore, this ear simulator is actually very, very good for testing actually all types of headphones. On the ear, over the ear, earbuds, and in the ear headphones. When we are talking about in-ear headphones, then we know that we need an ear canal for testing these. For doing production tests of these, we could actually use a coupler. It could be a 2cc coupler or an 0.4cc coupler. These couplers are normally used in the hearing aids industry for testing of hearing aids, but can also be used for testing earbuds and in-ear headphones, as they do have the cavity and they do also have a kind of an ear canal. If we have a little overview of the different ear simulators and microphones, and actually where can we actually use them in the different phases. In the R&D phase and in the production engineering phase, we can actually will normally use an ear simulator. And it could either be the IEC 60318-2 or -1. IEC 318-1 can actually be used for the headphone types on ear and over the ear. The IEC 60318-4 can actually be used for all types of headphones on ear, over the ear, earbuds, and in ear headphones. In production, we will very often go for a little more cheap solutions or cheaper solutions. And it means if we would like to test over the ear and on the ear, then we can actually use a plate with a microphone mounted inside the plate. For doing test in production environment of earbuds and in-ear headphones, we need a cavity, we need a volume, we need to simulate an ear canal so we can place our earphone inside the ear canal. And for this, we could actually use, as mentioned before, the 2cc or the 4cc ear coupler. If we have a look at the 45cc test fixture, then the 45cc is a very flexible platform which actually offer a lot of advanced tests on headphones. And yeah, the fixture is actually not complicated to use. It's actually easy to use, and it's not so expensive. So it is actually a perfect solutions for your product line testing. The fixture is designed so you will get a very high reproducible test, and it will also give you a very fast test, and that's actually due to you have this positioning guides here, so it's easy to mount the headphone in exactly the same position as it was mounted the last time you did the same test. We have a complete range of configuration available for this 45cc, going from high frequency IEC 60318 ear simulators with anti-brumetic pinner, and anti-brumetic pinner is a human-alike pinner where we also have a human-alike ear canal, to flat plates with microphone mounted. Let's have a closer look at the 45cc. 45cc, with the 45cc, it's actually easy to adjust. First of all, adjust the distance between the ears. It's just losing some screws and then moving the plates and find the right position. It is actually important that we have the right position between the ears, because if we don't have the right position, then we might not have the right pressure or the right force from the headphone on the ear check plates, on the check plate, and it means that we might have leakage. So to avoid leakage, then it's very important that the distance between the ears are correctly. We have also an easy adjustment of the headband at the height of the headband holder, so we actually will find the right positioning, the central positioning of our headphone cup. To align the headphone cup, we have actually the positioning guides, which also are easy to adjust. And when we have adjusted them, then we will fix them with some screws, so nobody can remove it, and therefore we can do a lot of tests with the headphones in exactly the same position. The 45cc can also be delivered with a mount simulator or delivered with accessories, so it's easy to mount a mount simulator, so you are able to do tests of headsets as well. The platform the fixture is placed on is a heavy platform, and it means that you will have less influence of vibration coming from the environmental surrounding you have around you. It is easy to remove the microphones or ear simulators, as these have been mounted with a special snap fitting system, so it's easy to dismount and mount these again, for instance when you are doing calibrations and validation of the microphones or ear simulators used for the fixture. Again, a little overview here of the 45cc. The 45cc can be delivered with a flat plate, either with a 1/2 inch microphone or with a 1/4 inch microphone installed. The size of microphone depends on if you would the frequency range of interest. If it's a 1/2 inch microphone, then you can measure up to about 20 kilohertz. If it's a 1/4 inch microphone, then you can measure up to 50, 70 kilohertz. You can also get the system, or the 45cc, with an IEC 6218-1 ear simulator mounted. The plate and the IEC 6218 ear simulator, these configurations can be used with on-ear and over-the-ear headphones. For testing in-ear and earbuds with the 45cc, you will need an ear canal, so therefore you have to go to the newer version of the 45cc, the versions which actually have the IEC 6218-4 ear simulator mounted. Let's have a short look at other fixtures. We have the 43AG, an ear and cheek simulator. The 43AG is a perfect little test jig for R&D, actually for fast and easy test of prototype. When you are developing new headphones, then it's a good little bench tool for doing a lot of easy tests. It's the same type of ear simulators you have there, and it's the same type of pinners you are using. And the 43AG is actually also available in a version where you have the anthropometric pinner. For doing a final test, type approval test maybe according to the IEC 60268-7 standard, the KEMA can be used. KEMA is actually used where you would like to have very realistic test in a sound field where you are doing a complete set of measurements on your headphones. In R&D, you can also use the 45CA. The 45CA is a fixture with an extremely high self-inserting loss. And of course, the 45cc can also be used in R&D for doing for doing validation and final test measurement. In your production, then the 45cc is a perfect system for test of on-ear and over-the-ear headphones. For test of in-ear and earbuds, and then where you need the ear canal, you can either use the 45cc with the IEC 60218 ear simulator, or you can use the fixtures called 43AC, which is also an IEC 60218-4 ear simulator with the wanted ear canal, or as discussed on one of the previous slides, a 2cc or a 0.4cc coupler can be used for your production line testing. When we are in production line, when the chances, when we are in a production line testing, then we might have a lack of standardization. There's no standardized way of doing production line testing of a headset. There are standard way of doing it when we are talking in R&D and we are talking about type approval, because then we have to go back to the IEC 60268-7 standard, which actually describe what to do. But in the production line testing, it's actually more or less up to yourself finding out what type of test do we actually have to carry out. We all know that the consumers of today, they would like to have a very high sound quality, of their headphones. And it means that we have, in some cases, to do more sophisticated tests. We have to use more advanced test equipment for doing these tests, for fulfilling the demands from the market. In many cases, we will in R&D set some targets for our test, but we will probably not make the test in our production line on exactly the same way as we did in R&D. It will, in some cases, maybe be too expensive. On our production line, it is very important that we are able to repeat our measurements, that we are able to get the same results every time we are doing these measurements. And it means that, first of all, it should actually be easy to fit and place the headphone on the test in the test fixture. We should not have any problem when we are putting it in, because if we have problems, then it will take extra time to place it. And yeah, time is money. In our R&D, we would actually like to make realistic tests, but in a production line, it's not necessarily what we want to do. In the production line, it is actually more important that it's easy to set up the test, that it's easy to do the test, and we will get the same results. And we would actually like to have the same result, also up in frequency, as we saw on the demand from the consumers that they would like to the headset to be able to measure up to higher and higher frequencies, or work to higher and higher frequencies. And it means that that we also need reliable measurements, that we are able to repeat our measurements also up to these high frequencies. Should we use an ear simulator of one type or another type, or a flat plate? What is the easiest way for doing this? Let's have a little talk about these things. First of all, let's have a little look at our IEC 60380-4 ear simulator family. We have actually totally 3 different ear simulators, all fulfilling the IEC 60380-4 standard. We have the one we call the standard ear simulator. And if we look at the graph here, where we have the data, where we have the frequency response, then we can see a dotted line. The dotted line is actually the tolerances given from the standard. And the standard describes that you can use this ear simulator from 100 Hertz up to 10 kilohertz with these tolerances as given with the red dotted line. And then the ear simulator has a resonance frequency. A resonance frequency on 13.5 kilohertz is a halfway resonance. We have made something we call a high frequency ear simulator. The high frequency ear simulator has a frequency response from 100 Hertz up to 20 kilohertz. So we have actually extended the working area of the ear simulator from 10 kilohertz to 20 kilohertz. And this has actually been done by damping the resonance. We still have it, but we have damped the resonance, and it would actually give us a very reliable measurement between 10 and 20 kilohertz. Some of you are interested in measuring even higher up in frequencies. Some of you are interested in measuring according to the high-res standard, the high-res Japanese standard, up to 50 kilohertz, and that's actually possible with our high-res ear simulator. The high-res ear simulator has, as the other 2 types of ear simulator, the same response up to 10 kilohertz. The high-res has also the same response from 10 to 20 kilohertz as the high frequency ones. And then we actually have a very well-defined response from 20 kilohertz and up to 50 kilohertz. The IEC 60380-4-1 ear simulator do also have a very well-defined transfer function or frequency response. If we compare the response we have here for the IEC 60380-1 with a standard microphone, with a standard pressure microphone, then we can see that the standard measurement microphone has a very flat frequency or response up to, in this case, up to 20 kilohertz. When doing realistic measurements, then we talked about in the beginning that it is important that we load our headphone with the same load as the impedance for the human ear. And we have actually done it here, where we can see that we have the gray line, the gray curve. The gray curve is actually what we measure on a realistic setup, and then in R&D, then they will probably set some limitations or some tolerances according to this curve. After that, then we will actually do the same measurements, maybe with a flat plate, a cheaper solution, and then we will actually see that it will probably start falling off at higher frequency. And now we will actually use this as a target curve for our production. So the black curve will actually be the target curve for our production. So all the headphones will actually be tested up against this target curve, plus minus a tolerance. This was actually the words in part 1, and now Santiago will continue with part 2.
Thank you very much, Ole. That was very interesting. So let's continue with the second part of this webinar. I'm going to focus a bit more on the audio precision part, the AP part. For the ones in the audience that are not familiar with audio precision, this is the basic lineup of the company. We are selling audio analyzers. The current family of analyzers is called APX 500B series, and we have 9 different models. These analyzers are intended to be used together with AP software, which is called APX 500 audio measurement software. Current version for this software is version 8. And we also have different devices such as power modules to drive microphones and measurement microphones, input and output switchers to connect multiple devices under test into a single analyzer, and many other things. So when it comes to using the audio precision APX system, it can be used to test many different things. We could perform electronic measurements for analog or digital audio. So it's not only analog audio, also digital, but also to perform acoustical measurements. And that is whenever we include a microphone and or a loudspeaker into a signal chain. Of course, in the case of headphone testing, or at least for this presentation, we are referring to the acoustical measurements of the headphones. You can see in the middle here that we have a long list of measurements, and each of these measurements can provide many different results. If we talk specifically about headphone testing, there are some basic parameters that we can measure. So one of them could be the frequency response. For example, for the left and right driver of my headphones, maybe we would like to measure the sound pressure level for a specific input voltage. In some cases, some people might be interested in measuring the electrical impedance of the different drivers in our headphones. Maybe we would like to measure distortion, such as THD, or any type of intermodulation distortion. You might want to test crosstalk attenuation from the left to right channel or vice versa. In some cases, we are also interested in measuring the left and right tracking to see how different the left and right channels are in our headphones, or just to double check if the wiring has been performed correctly in a production line environment. Maybe we would like to measure the output of the headphone for different input voltage ranges. And in some cases, some people are also interested in phase response and some other parameters. So we have many different types of analyzers. As I mentioned, 9 hardware analyzers, and these are basically the members of each family of analyzers. Up here on the left, the 555, this is our top of the line. This is the analyzer with the best performance on the market in terms of audio analyzers. Then we have other analyzers such as the 8X family for multi-channel measurements with this type of analyzers, you can get up to 16 analog inputs and 8 analog outputs. These are for simultaneous measurements. Then we also have the APX Flex, which is very interesting because this analyzer will allow for the use of third-party hardware with the APX 500 software from Audio Precision. Third-party hardware such as audio interfaces, for example. And up here, we have the latest member of the family, which is the APX 517. This analyzer has been specifically designed for electroacoustical measurements, and it's the analyzer that I'm going to be using today for the demonstration. Just so you get a basic idea about the differences between these analyzers, here I have some of the analyzers of Audio Precision, and you can see that the basic differences are related to the amount of analog inputs and outputs, but also related to the performance of the analog analyzer itself in terms of bandwidth or the maximum input voltage that they can measure. We also have differences in the signal generator that is in each analyzer in terms of the frequency range of the signals that we can generate, but also the maximum amplitude of the signals that we can generate. And also in terms of system performance, there are some differences in terms of total harmonic distortion plus noise, as you can see, but also in the noise floor of each analyzer. This is something that we are very proud that we can provide accredited calibration according to ISO 17025. This is not very common in the industry. So before releasing the APX 517, the analyzer that I'm going to be using today, the typical setup that we're recommending or using for performing electroacoustic measurements with our analyzers, it was by using a device called the APX 1701 transducer test interface. It's a device you see down here. So this device is not an audio analyzer, but it's meant to be used together with an audio analyzer, like in the setup you see down here. So this device, this transducer interface, is basically adding some capabilities to the analyzer. For example, we are adding a power amplifier that can be used to drive a loudspeaker or a pair of headphones. We also have microphone inputs with plus 48 phantom power or with CCP, ICP power supply for measurement microphones. And we also have a current sense input for loudspeaker impedance test if that's needed. This device is compatible with TETS, so if you're using measurement microphones or any sensor with a TETS chip, you will be able to rely on this technology. But as I mentioned before, we now have the APX 517 audio analyzer, which is the device you see up here. This analyzer is basically taking the capabilities of an AP audio analyzer and adding some of the capabilities of the 1701 transducer interface. So for example, you will find a power amplifier for driving loudspeakers. Then you have a headphone amplifier for driving wired headphones. And then we have two inputs that can work as microphone inputs with both plus 48 volt phantom power or CCP, ICP power supply for measurement microphones. And on top of that, we also have the possibility of adding digital inputs and outputs on this module over there. In this picture, we are showing the APX 517 together with a Bluetooth Duo module. We have some other options. This analyzer can be used together with the APX 500 software, and in the basic configuration, you will find a lot of different measurements and measurement results that can be used to test speakers, such as loudspeakers or speaker drivers, microphones, headphones, or headset, everything into a single box, a complete solution. As I mentioned, we have this slot here where you can mount optional modules, and we have different options here. I already mentioned the Bluetooth Duo module that can be used for testing Bluetooth headphones or any Bluetooth compatible device such as automotive head units or smart speakers. But we also have other modules such as the digital serial inputs and outputs, PDM, HDMI, ARC, and others. In the case of the headphone amplifier, whenever you purchase a 517, you have to decide which type of connector you would like for the headphone amplifier. We have a 3.5 millimeter, PNC, or quarter-inch TRS. You can get more than one of these panels because the panel over there for the headphone amplifier is user replaceable. So you can change it depending on your needs. Over here, I'm leaving the detailed specifications of the APX 517, so you can look at them later. And up here, you will find a link to the data sheet of the APX 517, where you will find even more information. So this analyzer, such as any other AP analyzer, is meant to be used with the APX 500 software from Audio Precision. And the software is a very versatile and powerful that will allow you for one-click measurements and get fully automated reports. The basic package of the 517 comes with different measurements, and one of them is called loudspeaker production test. This is not only useful for testing loudspeaker, but for any electroacoustic application, such as testing headphone, because you will be able to measure different results, and some of them are mentioned here, and are useful for any electroacoustical measurement. So the idea with this software is that you can get a code-free automation using the sequencer on the navigator. But if you're already working with an API, we also provide a full API for the APX software, so you can use it with any VB.NET compatible language, such as C#. You can also use it in a MATLAB or LabVIEW environments. We have some customers using Python as well. But I think the best thing in order to show you the functionalities of the APX 500 software would be via demonstration. So this is the plan for today. I'm going to be using the following setup, using a 45cc that Ole presented before, with a pair of wire headphones that are connected to our APX 517. But I'm going to be describing this during the presentation. The analyzer is connected to a PC running the APX 500 software. If you don't hear audio at the start of the video, then please check your computer's audio output settings, not the GoToWebinar audio settings, but your computer's audio settings. So you can select the device that you want to use for hearing the audio. You will note that the presentation in the video it goes a little bit fast, but the idea is that you get the basic idea on how to work with an Audio Precision project file and how to understand it and how to make it yourself. You will receive a copy of this video later this week, so you will be able to follow everything step by step and pause the video. But we are also giving you extra material by the end of the webinar, extra videos and extra application notes and things that you can read to get more insight on the topic. So without further ado, I'm going to start with a video demonstration. So let's start this headphone test demonstration by describing the setup we have over here. So this is the APX 517B audio analyzer, and this one is the GRASS 45cc test fixture. The ear simulators in the test fixtures have microphones and preamplifiers that are connected directly into the two inputs of the 517. Then I have a pair of wired headphones that are connected directly into the stereo headphone amplifier output of the 517. Now let's go to the software. So this is a start screen of the APX 500 software. I think a good idea to start with this demonstration is to base all our testing in the TechNode 143 that you can find in the AP's website, but also together with the handouts of this webinar. If you download the TechNode 143, you will find two files. The first one is a project file, and the second one is a technical note that has a description of everything that is shown in the project file, with descriptions step by step on how to understand and perform the measurements. As we can see, this is a complex project file with 4 different signal paths and many different sequences as well. A sequence is basically a combination of checked items such as signal paths and measurements in the navigator. So the first sequence is for calibration of the ear simulators in the test fixture and regulation of the headphone amplifier output. The second sequence is related to the acoustic measurement themselves, so we can get all the results related to the measurements of our headphones. The third sequence is the impedance measurement of the left and right channels of our headphones. And the last sequence includes all the previous sequence played one right after the other. So now it is time to test my sequence. In order to do that, I'm going to grab the headphones and mount them on the test fixture in a way that I make sure that there's a good sealing between the headphone and the plates of the ear simulators. This way, I know I'll get reliable test results. I can click on Run Sequence. To continue with this demonstration, I will try to replicate from scratch the first sequence of this project file for the calibration of the ear simulator and regulation of the output of the headphone amplifier, but also the second sequence related to the acoustical measurements. So in order to recreate the project file we just reviewed, I just open a brand new project. This is the first thing you see when you open a new project. The first thing we need to do is to set up the signal path. Then I'm going to set up my reference for the auto generate level. I have renamed my project to replicate headphone test, as you can see over here. Now it's time to work on the navigator. Then I will need to work on the sequence steps. The next step will be creating a new signal path. Next step will be going to the measurement sequence settings. And this is a very important thing. I need to check the auto set generator level checkbox, because in this step, we're gonna set up the generator level of the headphone amplifier output. And this is going to be related to the reference pane over here. We're gonna click auto generator level, and this will going to regulate to an RMS level with a target value of, let's say, 94 dBSPL at 1 kilohertz. Another thing is that at this step of the sequence, we are going to be copying all the calibration references from the signal path number 1, and that's going to be the sensitivity of channel 1 and channel 2 that we measure with the sound calibrator. Now I'm going to work with the sequence steps of this signal path. I'm going to move this prompt before the step where we start with a measurement of this signal path. Then I'm going to add the first measurement of the signal path number 2, and it's going to be the measurement that will give us all the acoustic test results for the headphone test. For this demonstration, I'm going to be using another module called the acoustic response. Now that the acoustic response module is part of the sequence in my signal path number 2, I'm going to work on the signal and the sequence steps inside the acoustic response measurement. The first thing I'm going to do at the moment that we are regulating the output of the generator, I would like to make the RMS result visible so the user can see the level of the output generator of a headphone output. Next, I'm going to add a prompt. This is a part of the sequence where I would like to prompt the user to refit the headphones a couple of times. In order to do that, first I'm going to move these prompts to a place before the acoustic response measurement starts, and then I can continue adding the steps. First, a new prompt to refit the headphones. Next, I need to append the measurement result so we can see the multiple measurement results in the same chart. This is going to be measurement 2, the first refit. For the next step, I need to work on deciding which of the results are of interest for my measurement. Before going to the crosstalk measurement, I need to set the parameters for the acoustic response measurement. I could test the settings of my acoustic response measurement at the time. It doesn't matter at the moment that is not that my channels are not calibrated. but my test fixture is already connected to the analyzer as well as the headphones that are already mounted on the test fixture. So let's click on start. This won't start the sequence, but only perform the acoustic response measurement. So you can see we got some results, and we could work with these results so we can add some more interesting data. I could also compare the left and the right channels to see the difference. And there we have some extra results. The last measurement is going to be a crosstalk measurement. I have different ways of performing crosstalk measurements. In my case, I'm going to be using a sine sweep with one channel driven. So now this is partially finished. I could, for example, create different sequences. Let's remember a sequence is a collection of checked items. It could be different signal paths and measurements. In order to do that, we can go here and we can just rename each sequence and also add new ones. For this example, we're just going to keep one sequence that runs the whole measurement. So now we need to check all the items that we want for that measurement. Here we are going to set the generator output level and take the calibration references for the air simulator from the signal path number 1. And last but not least, we can add the report. And we can't forget about setting limits. The limits are going to determine if the measurement is passing or failing. And there are multiple ways of creating limits. Let's say we want to create a limit with a curve. We can simply go up here and draw the limits. We can add multiple points like this. But if you want to make something a bit more complex, we could take the shape of the curve we already have and set new limits related to the shape of the curve. And there we have some new limits. Of course, we can play around with the curves. We can smoothen these curves and set up the limits in whichever way we like. So now it's time to test the sequence. Before doing that, I'm going to the signal path number 1, the one related to the calibration of the ear simulator and regulation of the generator output. I'm going to the calibration box and I'm going to set the reference for the calibration. It's going to be 114 dB SPL at 250 Hertz. And then last but not least, I'm going to the pre-sequence steps and I will check the device ID prompt. So when the sequence starts, it will ask for the serial number of the device on the test. So without further ado, let's run the sequence. And with that, I will finish with the headphone testing demonstration so we can go back to the webinar. Okay, This is the end of the webinar. Would like to thank you everyone for attending. Remember, you're going to receive a copy of the webinar, including the video, so you can review that yourself. But here we also have a lot of material. So for example, we do have a YouTube channel for audio precision and GRASS. Particularly the audio precision's YouTube page has a lot of interesting videos showing step by step how to perform measurements for different applications, including for headphone testing. And I'm leaving here a link for that video. We also have a lot of technical articles from AP and GRASS, and we also have our blog where we discuss very interesting topics. I'm also leaving this application note that gives you a lot of information related to headphone testing as well. And remember that you can always go to the AP's website and download the APX 500 software. If you don't have an AP analyzer, you can still install the software and you can still run it in demo mode. So you can use it for practicing how to make the sequences, and you can play the sequences and get some random results.